Hi, I am B. Janardhan Reddy. In the previous videos, it was shown the derivation of formulae for finding the equivalent resistances when the resistors are connected in series and parallel manner. In this video, I will show you some problems on series and parallel connection of resistors. Okay, before going to solve the problems, here I will show you the formulae of resistors connected in series and parallel that we derived in our previous videos. Okay. Now let us remind the formulae that we derived in our previous videos. So here three resistors have been connected in series between the points A and B. Okay. So what is series connection of resistors? Let us see here. Series connection of resistors. In the series connection, the resistors are joined one after the other. Okay. In figure below, three resistors R1, R2 and R3 are connected in series between the points A and B such that one end of the resistor R1 is connected to the point A and its other end to the resistor R2. The other end of the resistor R2 is connected to one end of the resistor R3 and the other end of the resistor R3 to the point B. So this type of connection is called series connection. Now if these three resistors are connected in series, what is the equivalent resistance between the points A and B? And here is the formula. Rs equal to R1 plus R2 plus R3. Here Rs is the equivalent resistance when the resistors are connected in series. Okay. When resistors are connected in series, current finds only one path to pass from point A to point B. Isn't it? So the equivalent resistance is equal to sum of the individual resistances. Like this, we can connect as many resistors as we want. So this is the first formula in resistors. Now let us see another formula. If there are n equal resistances, each of value are connected in series, the equivalent resistance is equal to, see here, Rs is equal to R plus R plus R plus up to n times, then we'll get n into R. So in this formula, n is the number of resistors and R is the resistance of each resistor. So Rs is the resultant resistance. So when n resistors having R resistance are connected in series, the equivalent resistance can be found by using this formula, that is Rs is equal to n into R. Okay. Now let us see what is parallel connection of resistors. See here in this figure, three resistors R1, R2 and R3 have been connected in parallel between the 2 points A and B. Okay. So in parallel connection of resistors, one end of each resistor is connected at point A and the other ends of each resistor is connected at the other point, say B. Okay. So let us see what is parallel connection of resistors. Parallel connection of resistors. In the parallel combination or connection, one end of each resistor is connected at one point, say A, and the other end of each resistor is connected together at the other point, say B. The battery along with a key K is then connected in between the points A and B as shown below. Okay, so here three resistors of resistances R1, R2 and R3 have been connected in parallel between the 2 points A and B. So in parallel connection of resistors, current finds more than one path to flow from point A to point B. If one resistor is removed or gets damaged, it does not affect the flow of current. Current flows continuously in the circuit. Okay. So if these three resistors are connected in parallel between the 2 points, then what is the equivalent resistance? We derived the formula for the equivalent resistance in the previous video. Here I am giving you the formula directly without derivation. So 1 by Rp. Rp means equivalent resistance in parallel connection. So 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. That is the reciprocal of the equivalent resistance is equal to sum of the reciprocals of the individual resistances. So this is the formula we have to use when the resistors are connected in parallel to find the equivalent resistance. Okay. Now see here. If there are n equal resistances, each value are connected parallel, the equivalent resistance is, you see here, 1 by Rp equal to 1 by R plus 1 by R plus 1 by R, like this up to n terms we get n by R. So 1 by Rp is equal to n by R means if you take cross multiplication and simplify, we get Rp is equal to R by n. What is Rp? Rp is the equivalent resistance in parallel connection. R is the resistance of each resistor and N is the number of resistors. Okay. When two resistors R1 and R2 are connected in parallel, we calculate the equivalent resistance directly here. One formula, see here, 1 by Rp is equal to 1 by R1 plus 1 by R2. Let us simplify it. So 1 by Rp is equal to R1 R2 by R2 plus R1. By taking LCM, we get R1 R2. Okay. So after simplification, we get R2 plus R1 by R1 R2, or Rp is equal to R1 R2 by R1 plus R2. So when the two resistors are connected in parallel, the resultant resistance is equal to product by sum. Product of the two resistances divided by sum of the two resistances. Okay. Now I put all the formulae together. You see here, formulae of resistors, formulae or formulas. Okay. See here, whatever we have seen so far, I am putting together here. First one is RS, equivalent resistance in series connection. RS is equal to R1 plus R2 plus R3. This is the formula we have to use when resistors are connected in series connection to find the equivalent resistance. And RS equal to NR. When n resistors, each value R are connected in series, the equivalent resistance can be found by using this formula. Rs is equal to N into R. N is the number of resistors and R is the resistance value of each resistor. Next, and this is the formula we have to use to find the equivalent resistance when the resistors are connected in parallel. Okay, and Rp is equal to R by N, that is when N resistors each of value R are connected in parallel, we have to use this formula to calculate the equivalent resistance. Here Rp indicates equivalent resistance in parallel connection and R is the resistance of each resistor and N is the number of resistors. And just now we have seen these two. Rp is equal to R1 R2 by R1 plus R2. That means this formula can be used only when two resistors are connected in parallel. So Rp is equal to product by sum. Okay, R1 R2 by R1 plus R2. So these are the formulas for finding the equivalent resistance of resistors. Okay, now let us go for some problems. Here is the problem number 1. Three resistors of 2 ohms, 3 ohms and 4 ohms are connected in A series, B parallel. Draw the arrangement and find the equivalent resistance in each case. So three resistors have been connected, once in a series manner and next in parallel manner. So what will be the equivalent resistances in each case? See here. Solution: given R1 equal to 2 ohms, R2 equal to 3 ohms and R3 is equal to 4 ohms. The series and parallel arrangement of resistors are shown below. You see here, this is the series arrangement. 2 ohms, 3 ohms and 4 ohms. We have been asked to draw the arrangement. I have drawn the series connection here and here is the parallel arrangement. Okay, so between these 2 points, 3 resistors have been connected in series. In this case, the 3 resistors 2 ohms, 3 ohms and 4 ohms have been connected in parallel. So what is the resultant or equivalent resistance in each case? Let us find it. Now let us calculate the equivalent resistance in both cases. You see here in series connection, 2 ohms, 3 ohms, 4 ohms. R1 equal to 2, R2 equal to 3, R3 equal to 4 ohms, and the resultant resistance, say Rs is equal to, we know the formula, Rs is equal to R1 plus R2 plus R3. Let us substitute these values in this equation. We get 2 plus 3 plus 4 is equal to 9 ohms. Okay, and here the resistors are connected in parallel. So in parallel combination, the equivalent resistance is Rp. Then 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So let us substitute these values in this equation. 1 by Rp is equal to 1 by 2 plus 1 by 3 plus 1 by 4, and now we have to take the LCM of 2, 3, 4. You see here, R 1 by Rp is equal to, the LCM is 12 here. You can see here, 2, 3 and 4 LCM. So divide by 2, we get 2 1 is 2, take down 3 as it is, and 2 2s are 4. Then multiply these numbers, 2 into 1 into 3 into 2. 2 1 is 2, 2 3s are 6, and 6 2s are 12. So the LCM is 12. Now we have to divide the LCM by the denominator and multiply the quotient by the numerator. So if 12 is divided by 2, 2 6 are 12. We get 6 as quotient, 6 into 1 6, and in this fraction let us divide the LCM by 3. 3 4s are 12. 4 is the quotient, 4 into 1 4. Similarly 4 3s are 12, 3 into 1 3. So 6 plus 4 plus 3 is equal to 13 by 12. So 1 by Rp is equal to 13 by 12. And if you reverse this fraction, this also should be reversed. Otherwise you take cross multiplication and simplify, you get Rp is equal to 12 by 13, that is 0.92 ohms. And one interesting thing here you can observe, in the parallel connection, see here these three resistors are connected in parallel, and we got the resultant or equivalent resistance Rp value even less than even the smallest resistance connected. You see here 0.92 is less than all these resistor values. So in the parallel connection, the equivalent resistance Rp is less than even the smallest resistance connected. Okay, so this is the solution for the first problem. Here is the problem 2. What resistor must be connected to a 15 ohm resistance to provide an effective resistance of 6 ohms? See here, the solution is given R1 is equal to 15 ohms. R2 is equal to how much? So in order to get the effective resistance or equivalent resistance of 6 ohms, what resistor must be connected and how it should be connected to a 15 ohm resistor, that we have to calculate. See here, effective resistance R is equal to 6 ohms. Since the effective resistance has decreased, so R2 must be connected in parallel with R1, isn't it? So the combination of these two resistors, the effective resistance of these two resistors has been decreased. That means the resistor that we are going to find out its resistance value must be connected in parallel with R1 15 ohms resistor. Okay, so Rp is equal to 6 ohms. That means this is the equivalent resistance when these two resistors are connected in parallel. So here is the formula. In parallel connection, we have Rp is equal to product by sum R1 R2 by R1 plus R2. So let us substitute these values, Rp value and R1 value, in this equation and simplify. 6 equal to 15 into R2 by 15 plus R2. Here R1 is 15 ohms and R2 we do not know, that we are going to find out. And RP we have known 6 ohms. So let us take cross multiplication. 6 into 15 plus R2 is equal to 15 R2 means 15 into R2 here. So 6 into 15 90 plus 6 R2 is equal to 15 R2. If you transpose plus 6 R2 to this side, we get 15 R2 minus 6 R2 is equal to 90, or 9 R2 is equal to 90, and R2 is equal to 10 ohms. 90 divided by 9 we get 10 ohms. Okay, so this is the required answer. So thus a 10 ohm resistor must be connected to a 15 ohm resistance to provide an effective resistance of 6 ohms. Okay, that means if 15 ohms resistor and 10 ohms resistor, if they are connected in parallel, we will get the effective resistance as 6 ohms. Let us go for the next problem. Problem 3. Three resistors of 6 ohms, 3 ohms and 2 ohms are connected together so that the total resistance is greater than 6 ohms but less than 8 ohms. Draw a diagram to show this arrangement and calculate its total resistance. See here, we have been given 3 resistors and we have to connect them in the combination of series and parallel so that the total resistance must be greater than 6 ohms and less than 8 ohms. Okay, so we have to draw a diagram to show this arrangement and we have to calculate the total resistance. See here, solution. Since total resistance is to be greater than 6 ohms, therefore 6 ohm resistor should be in series with the other resistors, the equivalent resistance of which is less than 2 ohms, so that the total resistance is less than 8 ohms. Now, to have a resistance less than 2 ohms, remaining 3 and 2 ohms resistors should be combined in parallel. So the arrangement is shown in figure 3.1. See here, we want the total resistance greater than 6 ohms. That means 6 ohm resistor should be in series with the other resistors, that is 3 ohms and 2 ohms resistors, and the equivalent resistance of which is less than 2 ohms, so that the total resistance is less than 8 ohms. Okay, so now to have a resistance less than 2 ohms, that means we want the total resistance greater than 6 ohms and less than 8 ohms. In order to get like this, we have to connect these 3 resistors in this manner, like this. You see here, 6 ohms, 2 ohms and 3 ohms. So 6 ohm resistor should be connected in series with 2 ohms and 3 ohms resistors, whereas 2 ohms and 3 ohms, these two resistors must be connected in parallel, because the total resistance should be less than 8 ohms also. If they are connected in series, we get the total resistance greater than 8 ohms. For that reason, 6 ohms resistor should be connected in series with the parallel connection of 2 ohms and 3 ohms. See here. So let us calculate the effective resistance of these 3 resistors between the points these two are connected in parallel. Parallel connection means product by some 2 into 3 by 2 plus 3. See here, for resistors of 2 ohms and 3 ohms in parallel, the equivalent resistance Rp is given as R1 R2 by R1 plus R2, or Rp is equal to 2 into 3 by 2 plus 3, we get 6 by 5 equal to 1.2 ohms. So the equivalent resistance of these two resistors connected in parallel is equal to 1.2 ohms. That means we can remove these two resistors and we connect a single resistor of resistance 1.2 ohms in series with the 6 ohms resistor. The arrangement in figure 3.1 takes the form as shown in figure 3.2 like this. Okay, 6 ohms and here 1.2 ohms. Again, these two resistors are in series, and to get the equivalent resistance, just we have to add these two values. 6 plus 1.2, we get 7.2 ohms. So total resistance of arrangement equal to 6 plus 1.2 equal to 7.2 ohms. Okay, so this is the required answer. Now here is another problem, problem 4. Calculate the equivalent resistance between the points A and B in the circuit shown in figure 4.1. See here, here is the circuit. Okay, so in this circuit, 3 resistors have been connected between the points A and B in this manner. Now we have to calculate the equivalent resistance between the points A and B. So we can observe here these two 6 ohm resistors are in series. That means same current flows through them. So 6 plus 6 we get 12 ohms. So we can remove these two resistors, isn't it, and connect one single resistor of resistance 12 ohms in parallel with 6 ohms. So see here, here is the solution. In the circuit, two resistors 6 ohms are connected in series. The equivalent resistance of this series combination RS is equal to 6 plus 6, we get 12 ohms. So let us remove these two resistors, and in place of them I am connecting a single resistor of 12 ohms with parallel to 6 ohm resistor. The equivalent resistance RS equal to 12 ohms is now connected in parallel with a resistor 6 ohms between points A and B as shown in figure. So if I remove these two resistors and I connect only single resistor 12 ohms, and this figure takes the form like this: 12 ohms and 6 ohms. Now these two resistors are in parallel between the points A and B. When the two resistors are connected in parallel, the equivalent resistance Rp is equal to R1 R2 by R1 plus R2. If the equivalent resistance between A and B in figure 4.2 is Rp, then Rp is equal to product by sum R1 R2 by R1 plus R2. Let us substitute these values in this equation. 12 into 6 by 12 plus 6, that means 72 by 18, we get 4 ohms. Okay. Now let us go for another problem, problem number 5. In the circuit shown in figure 5.1, calculate the equivalent resistance between the points A and B. So here is the figure 5.1. Okay, so this is the circuit in which some resistors have been connected in this manner between the points say A and B. Okay, so we have to calculate the equivalent resistance between this and this point, isn't it? Now we can observe here we have three parts in this circuit. This is part 1, this is part 2, and this is part 3. So in the first part, three resistors of each 3 ohm are connected in parallel. In the second part also, two resistors of 4 ohm each are connected in parallel. So first we have to find out the equivalent resistance of these three resistors. Next we have to find out the equivalent resistance of these two resistors. And finally we have to join the equivalent resistances of this part and this part in series with 5 ohm resistance. Okay, now see here solution. In the circuit there are three parts. In the first part, three resistors each of 3 ohms are connected in parallel. If the equivalent resistance of this part is R1P, then see here, this is the first part, here is the second part, and this one is the third part. Okay, now I am going to calculate the equivalent resistance of the first part. If the equivalent resistance of the first part is R1P, so 1 by R1P is equal to 1 by R1 plus 1 by R2 plus 1 by R3. This is equal to 1 by R1P is equal to 1 by 3 plus 1 by 3 plus 1 by 3. We get 3 by 3. We get 1 ohm. So the equivalent resistance of the first part is 1 ohm. Okay. Now let us calculate the equivalent resistance of the second part, that is 4 ohms and 6 ohms are connected in parallel. The equivalent resistance of them is R1 R2 by R1 plus R2. So let their equivalent resistance of the second part, that is R2P. In the second part, two resistors 4 ohm and 6 ohm are connected in parallel. You can see here, if the equivalent resistance of this part is R2P, then R2P is equal to product by sum we get. So 4 into 6 by 4 plus 6, that is 24 by 10, we get 2.4 ohms. Now in place of these resistors, that is in place of part 1 resistors and part 2 resistors, I will connect single resistors, okay, in series with 5 ohms resistance. The two parts of resistance R1P just now we have got as 1 ohm and R2P as 2.4 ohm are connected in series with resistance 5 ohms between the points A and B as shown in figure. Now what is the equivalent resistance of these three resistors? That is part 1, we got it as 1 ohm. The equivalent resistance of the second part, here it is 2.4 ohms. I will replace these two parts with single resistors. Okay, 1 ohm, 2.4 ohm and 5 ohms. Again these three resistors are in series. So the equivalent resistance between the points A and B is RS is equal to 1 plus 5 plus 2.4, we get 8.4 ohms. Okay, so I will take up some more problems in the next coming video. Thank you.